Hello, welcome everybody to channel Sube. Today I am going to discuss question number 18, 2019 Physics MCQ new syllabus paper. 3 capacitors with equal capacitance and 2 batteries with equal electromotive force are given to construct a circuit to store energy. Which of the following circuits store the maximum energy? So there are 5 answers given. So what they ask is energy. So energy is given by the equation half q v, half q v, that is, this is the basic equation. How this equation come? So think of an object. I take a sphere, doesn't matter the shape of the object. So initially this object has no charges. So the first charge we bring from infinity to load this object. Then it is easier because nobody repel or attract. Very easy. Then that charge is here now. When we bring the second charge to load this object, it is very difficult to bring that charge to this object because by this early one the second one is repelled. There is a force, repelling force. So therefore it is very difficult. So after second one, so there are now 2 charges already. So we bring the third charge. That will be more difficult because both these people repel this incoming charge, so we have to do more work. That means we have to spend more energy. So that energy is stored in this object that is called V for 1 coulomb. The energy for 1 coulomb is called V, voltage. So like that Q increases, the same way V increases. So the graph is like this. Q increases, the same time voltage also increases. So the graph is like that. So we have to find the final energy. Then how we do final energy, final electric potential energy? So energy equals, Q times V, because V is the energy for 1 coulomb. The simple Q is the energy, the total charge. So let's take capital Q because we used the capital Q. So this is the equation. But this voltage is not constant. Initially it was 0. Finally the value we take down, what we record, it is the final value, just we say it is V. So we have to then use therefore mean value of V. So we get Q. How to find mean value? Initial value 0, final value V, 2 items divided by 2. So the same way now we have to multiply it by this mean value. So what we get is Q times the 0, no need, V divided by 2, then half times QV energy equals. The same way you remember in elastic, the lesson elasticity, what we did, the same way. The initial force of the wire, the tension is 0. The final tension of the wire is F, that is what we record finally. So the extension is E. So work done equals energy. So to find energy we have to get work done is F times displacement. So energy equals then F. F is not constant. At the beginning it was 0, finally it was F. So therefore we have to use mean F, average F times displacement is E. Here displacement is E. Then we take initial value plus final value divide by 2 because 2 items times E. The same way. So half times F E. So this is how we derive the energy for elastic potential energy. So you don't have much difficulties to keep in your mind this equation, how to derive it. If you forget, you can derive it at the time you need it. So this way you get the same way half QE. So you can use that equation here to solve this question, half QE. That is what I used here at the beginning itself. But here you don't know Q. What you know is, you know voltage, because counting batteries you can guess what is the voltage, final voltage. You know then C, how you calculate C. Counting capacitors you can calculate, you can guess what is the final resultant C. So we need a equation without Q. Therefore we have to substitute, you know, Q equals CV. That equation here, from this you can get it. The C is defined Q per 1 volt. Q per 1 volt. Say 1 volt. What is Q here? So that is equal to C. So that is the definition. You should remember these things. Coulomb per volt. That is the definition of capacitance. So Q equals CV. That equation come from this graph. But you should remember the definition of C. What is C? Charge per 1 volt. Charge per unit volt. That is the definition for capacitors. So this, using this equation you can substitute here. Then energy equals half times here Q, then instead of Q you can write CV, then for this V again V. Now you get E equals half C V squared. So this is the equation now we are going to use, because C is there, V is there. C we can guess, V we can guess. We don't know about Q, that is why. So they ask maximum energy. So to get maximum energy, C must be maximum capacitance, voltage must be maximum. The maximum voltage we get when batteries are connected in series like this. If the voltage of a battery is 3 volt or 1.5 we say, then 1.5, 3, 4.5, 6 like that, final voltage is can be decided. Then we have to select the because maximum voltage we get when the batteries are connected series. So this one correct, batteries are connected series. This one wrong because batteries are connected parallel. This one correct, batteries are connected series. This one wrong. This one again connected series. This one correct. So the story about battery is done. Now let us consider this one, capacitance. What is the method of connection to get maximum capacitance? We know when the capacitors are connected parallel, we get the maximum capacitance. So like this, maximum capacitance. So you have to select that sort of a circuit. So this one wrong, this series. This one also wrong, series. Then this one correct. parallel, correct. This one correct, but batteries are wrong. This one wrong because series. So there are two correct marks here, both are correct. So the answer is third one. Thank you very much, children, for watching my videos. I think you understood. I started from the beginning itself, so this one is the beginning. If you haven't subscribed my channel, if you are happy, subscribe. Please subscribe my channel. See you tomorrow. Have a nice day. Goodbye.